Dr. Raven is a world-renowned environmentalist and the President Emeritus of the Missouri Botanical Gardens. He's also a member of the Pontifical Academy of Sciences, for which he is currently advising Pope Francis on his upcoming encyclical on climate change. So please join me in welcoming our speaker, Dr. Raven. Oh, and following the talk, there will be some Q&A, so.
Thanks very much. It's a pleasure to be here. Father Gary said I should read a poem first before starting to speak, so I picked the following poem. Whether it has anything to do with what I'm going to say later, it's for you to figure out. I think it actually does, but that will be for you. The poem I've selected is Lines Written in the Days of Growing Darkness by Mary Oliver. Every year we've been witness to it, how the world descends into a rich bash in order that it may resume, and therefore, who would cry out to the petals on the ground to stay, knowing as we must, how the vivacity of what was is married to the vitality of what will be. I don't say it's easy, but what else will do if the love one claims to have for the world be true? So let us go on, though the sun be surging east, and the ponds be cold and black, and the sweets of the year be doomed. So that's all I wanted to say tonight. I'm now open to questions. Actually, what I want to do is will be more in the nature of a discussion than in the nature of a speech. I will be glad to be interrupted at any point. I'm going to, just to give you an outline of where I'm going over the next 45 minutes or so, I'm going to start with some remarks about science, farming, biochemistry, what the nature of the manipulation of genes is, food safety, and then at that point I'll probably stop when I've gotten to food safety, if not before, and have some questions. And then I'll go on and talk about effects on the environment, effects on biodiversity in crops and in wild species, related species, and then finally onto issues of morality, ownership, availability, and so forth of the genetically modified organisms or products. So starting with science, many of you are scientists or incipient scientists or have a scientific bent of mind, and you will know that science is an orderly process which is in its modern form about 800 years old, and which depends on the proposal of hypotheses about the nature of things, about subjects that are under study, and then the criticism of those hypotheses by whatever peers want to criticize them, the publication, open of them, and so forth. And then either they're falsified or they're not falsified. Science, and this is a very important point, it probably underlies the whole discussion. Science is not a matter where all voices are equal. Science is an orderly process that leads to logical, agreed-upon conclusions. And of course, there doesn't need to be a clear conclusion or a clear theory of why things are as they are in a given area, but there will always be, that will always be in development. And when we look back, of course, things that have been totally accepted in science have eventually been falsified and some other explanation has been found. But at any given time, there will be, for any idea that anybody's considering, there will be a particular notion of what the general accepted view is. Therefore, if I'm a writer or a commentator and I just get up and say, I think this all sounds like a bunch of hogwash, or it's a plot to do something or to tell somebody about something, that's really a mistake to pay much attention to that, because it's not based on the kind of logic on which science really depends. It's based merely on ideas. And usually arguments of that sort are based on the desire of the person speaking to avoid taking action that they believe would be necessary if they accepted the basic fact. But science doesn't tell you not to jump off a 7-story building any more than it tells you what to do about global warming. It just tells you what the consequences will be if you go on with your actions. And it's very important to understand that science does not provide solutions, it provides the basic facts on which solutions can logically be based. The second ideas I would say, or second points I would make, are about the nature and growth of farming in the world. Human beings or species like us have been around for about 2.2 million years, which is a relatively short time in the history of the Earth, which is 4.54 billion years. 2.2 million years would be the current idea. And our ancestors began to develop the cultivation of plants, first in relatively patchy ways, and the domestication of animals. Dogs were domesticated earlier than this, but other animals later. Cats have never been domesticated. At any rate, about 12,000 years ago, people began to deal with crops. And by about 10,000 years ago, people had actually began to depend on them. They had foods that they could use to pass unfavorable seasons, and they could store them, they could use them in times of need, and as they began to cultivate them, they began to change them in their characteristics. But what it's kind of important to know in terms of the whole world picture is that at 10,000 years ago, when these abilities were first becoming a standard part of the lives of people, who were therefore able to build up villages, towns, cities, states, and so forth, because of the extra supplies of food. About 10,000 years ago, the population of the entire world was about 1 million people. 1 million people. That would be about 10 days net increase in the population of the world at the present time. And that 1 million people, there were about 100,000 in Europe, and that 1 million people lived as hunter-gatherers. They go around in groups of like 20 to 40 or 50 people. There couldn't be the kind of specialization that was possible when large numbers of people were living together. And those groups, when they found food, when they could get food, or when they could find food, they had to consume it pretty fast, because most of it really couldn't be carried along with them, and there was nothing much else to do. Now, as people began to be able to depend on cultivated plants and domestic animals, their numbers began to increase. But even so, by the time of Christ, 2,000 years ago, there were probably only 300 million people in the world, smaller than the population of the United States at the present time. In the whole world, we tend to think of it as always being full of people, but that's not really true. Written language was developed about 5,000 years ago, about halfway along the way, and the various specialties that could be developed in villages, towns, and cities where people could live together, whether those specialties be as civic or religious leaders, as musicians, as storytellers, as lawyers, as farmers, or whatever, those specialties that could develop in those building urban settlements or smaller urban settlements formed most of what, the great majority of what we now call civilization at the present time. So civilization, as we know it and as we prize it, is a very new development. With the invention of written language, of course, ideas about what was going on could be transmitted directly in manuscripts, and before that they could only be transmitted through one generation of people telling another generation of people what they had observed or what they thought about the past, and then eventually that all came to be written down. As soon as people began to grow plants, they began to select them genetically, because inevitably, if you were growing a field of plants from seeds that you gathered in the wild, you would gather seeds from those that were bigger or stronger, or produced more fruit or more seeds or whatever it was that you wanted, more leaves. And as you did that, and as you selectively grew the seeds from those individual plants, you changed the genetic nature of the plants that you were growing from what they had been when they were growing in the wild. It's an automatic response to cultivation through generations. And looking ahead, if those plants were hybridizing with other plant species growing around them, weedy or wild relatives, their genetic diversity would be enhanced and the speed of the genetic change in those populations that were being cultivated would be accelerated. It was only about 1800 that some English wheat farmers first began to do something like what we consider genetic selection in the present sense. That is, they began to measure progeny quantitatively and to select on more measured grounds the individuals that they wanted to grow. With the what's usually called the rediscovery of Mendel's principles of genetics, which showed genes segregating, even though people didn't know at that time how that related to chromosomes, which happened about 1900, then what you might call scientific plant breeding began. And scientific plant breeding was developed as genetics was put back in place in the 20th century. And plants began to be selected in various ways for characteristics that were desirable, like better yield or bigger plants or more seeds or more food or resist pests better or whatever you were selecting for automatically. Among the methods used to get those plants, get the crops, to grow the crops from year to year were not only ordinary selection and not only artificial crossing, hybridization between different strains of the same plants, but also eventually things like using ionizing radiation to break the chromosomes up into chunks and then see where they fuse together and then just pick them, which happened fortuitously to combine the right genetic combinations with one another. And various kinds of treating with chemicals to double the number of chromosomes. All kinds of artificial breeding were used. A review that I wrote about 10 years ago with Perry Gustafson and Norman Borlaug about different kinds of plant breeding enumerates about 8 major kinds of genetic changing plants, one of which is transgenic modification, which I'll come to next. Now, one of the things that people say about genes moving from one organism to another is that it never occurs in nature. And one of the first things that I want to tell you is that's untrue. About 3% of our genetics, for example, is made up of viral genetics and others made up of bacterial genetics and so forth. And in fact, now that people have the tools to look for it, they find that horizontal transfer of genes is very common in nature and probably affects all organisms. One of the first things that was done in the modern period that caught people's attention was in 1973, when Boyer and Cohen, 2 eminent molecular biologists, transferred a gene from a bacterium, Escherichia coli, into the African clawed toad. And they went, oh my word, you know, that, and remember that was over 40 years ago. Oh my word, what have we got here? Are these hybrid things going to run wild and stomp out the world and so forth? And scientists were so concerned that they got together in 1975, 2 years later, in Asilomar, and led by Maxine Singer and other eminent, Paul Berg and other eminent biochemists and people worried about this, they installed a whole series of safety provisions for preventing these things from escaping from labs and doing anything harmful. After a while, they realized that this wasn't realistic, that they weren't going to escape from labs or do anything harmful, and so those restrictions were eased. But certainly science reacted 40 years ago with great alarm to the problem of transgenics, not knowing really what to expect. Then, and certainly more as time goes by though, we see that chromosomes that contain the genes are strings of genetic instructions, roughly analogous to a musical score, and that they can be rearranged or treated in various ways. And if they are, you don't change anything fundamental about the fact that they're still instructions. There's no such thing really as a pig gene or an Escherichia coli gene or a human gene, so that introducing them from one kind of organism into another does not create some kind of monster hybrid. It really changes the instructions on the chromosome of that individual recipient organism. And part of the fear about this, part of the fear that's generated, is that maybe if you combine them that way, you've created some new kind of monster. In fact, it's really more like picking up notes, as I say, in a musical score. The genes that go into new places often have to be modified genetically in order to fit and work in those new places. And of course, long before any genetically modified crop is ever released, commercialized, grown as a crop, it's gone through many, many generations and a great deal of inspection of how that gene fits into its chromosomes and how it's going to function in its new environment. Because a gene, although I've said it's a chunk of information instructing the formation of certain proteins that make up the characteristics of the organism, the way it synchronized, the way it's integrated with the other genes around it, and the exact way that it replicates itself is special in a context that has to be paid attention to produce an organism that will actually work. And of course, that's what companies or universities or people working on that spend a lot of time doing. Now, we've actually gone beyond transferring genes from one organism to another. We have gene editing, which is just coming out. And gene editing consists of changing the characteristics of genes within individual species of organisms so that they're different or give different results or have different products. And there's no commercial crop yet that was produced as a result of gene editing, but there are some which are ready to be released as a matter of gene editing. And it's thrown the naysayers into a real quandary because they haven't quite decided yet whether that's dirty pool or whether it's really sort of transferring genes in disguise or does something that's going to turn into a monster. None of which, of course, is really logical or true. In the 40 years since these techniques first began to become more intense, no one has identified a reason that moving genes around like that, changing them or moving them from one organism to another or changing their characteristics, has anything about it that's intrinsically dangerous or going to pose any risk by virtue of its own properties, by virtue of itself. Rather, they're technical ways of producing a different set of characteristics in the adult plants. And then we'd say food safety. What about food safety? A lot of the yak about this is about food safety. Well, the simplest thing to say about that is just give you some points. Hundreds of millions of people have been consuming foods derived from genetically modified plants for 20 years, and billions of farm animals have been doing the same, and not one single case of sickness or illness or irregularity or anything has been reported in a single human being or a single farm animal. That's hundreds of millions of people, billions of animals. For interesting, most of the fruits and vegetables that are out are not genetically modified, but the vast majority of the things that are in small quantities on the shelf there are. So about 70% of them in the United States have something from gene transferring from one organism to another, a product produced from an organism like that. And again, no case of sickness has ever been scientifically verified as resulting from that. What this all says is that food safety seems to be unquestionable, but you'll particularly think it's unquestionable when I tell you that virtually all the beer manufactured in the world is made from products of genetically modified organisms, yeast, virtually all of it. Virtually all the cheese made in the world is made from the products of genetically modified organisms. Virtually all of the white bread made in the world is made from the products of genetically modified organisms. A high proportion of our medicines are made from products of genetically modified organisms. That is, nobody concentrates guzlan from cows to make thymuses to make insulin anymore, because it's less pure than that made from the products of genetically modified organisms. Many other medicines, the cures that people are looking for Ebola, the cures that people are looking for citrus greening disease, which could wipe out all the citrus in the world and all, those all involve the products of genetically modified organisms, but nobody makes a peep about any of those. Since there's no difference in principle between them and a beer, cheese, bread, insulin, everything else we use all the time, and no one has ever found any difficulty of people getting sick or anything from consuming any of this stuff, why is it that we go on and on? Before I get into that, though, let me pause for a minute and call for a few questions about what I've said so far, because it's kind of fundamental to what I'm going to say later. Got you scared. Yeah.
Well, I'm curious about the food safety issue. I guess I'm wondering, why is it that in Europe they're so averse to GMOs, and I'm assuming that their scientists are just as well trained as they are in the United States. So I'm assuming that they're doing good science there. So why would
Why?
Why would that happen if it really is safe?
Every Academy of Sciences in the world most of them have studied this problem in detail, most of them a number of times. Most learned bodies, the Commission of the European Union, the government of Britain, which pulled out of Europe over this issue, and at least 99% of European scientists agree with what I just said. The problem is not that, the problem is political. Why, you might say, does it work better here, or why is there less talk about these things? Well, as strange as it may seem in this day of congressional dysfunction, we trust our government more than most people do in the world. The conclusions and recommendations of governments have often, come into question in various ways, and we just don't trust them. They don't trust them as much as we do. So, in the beginning, all the European governments said this was all swell, and then faced with the worry of consumers, they backed off, not on scientific grounds, but on sort of general worry grounds. Some of the general worry comes from things that I'm going to talk about later. So then food safety becomes an issue like global climate change. If you don't want to do what global climate change suggests that we need to do in order to produce a sustainable world, then one of the things you do is you attack the underlying facts. Well, I'll leave it at that for now, but that's basically it. But scientists in Europe think exactly the same as all the other scientists in the world, which is general agreement with what I've just pointed out. And of course, that's one of the strange anomalies of this. Why do so many Americans not accept evolution? Why do so many Americans, and the number is surprisingly high, believe that we didn't actually land on the moon, but it was fake? Why do so many Americans think that climate change is not occurring? Why do so many Americans fear vaccination? It's related. It's one of these. The March National Geographic magazine has a nice cover story on myths, anti-science myths, but a lot of them come about just because of the general sort of fair play feeling that what anybody says is equal to what anybody else says. And if you want to do the opposite, then you falsify the underlying message. Yeah?
I'm curious how the health impacts are being measured and tracked. Because it seems like there are a lot of whether allergies and other disorders that are on the rise that we don't know what the causes of those. And also we see young pigs in Missouri have been wiped out and
The what?
well, young pigs, for example, livestock's being wiped out sometimes with different bacteria and diseases that we don't know the cause of. So I'm curious how the impacts are being tracked. Because I can't imagine somebody's going to go to their doctor's office and say, well, I had some genetically modified bread last night, now I'm not feeling well. So how is that tracked?
Everybody in the United States, virtually everybody in the United States is eating genetically modified food regularly, and everybody studies this nonstop, and nobody's found a connection between that and the symptoms you're talking about. But what I want you to notice is that the method itself, genetic modification, can't be, there's nothing in common with all the things that are genetically modified. And the method itself, not having anything in common, can't be responsible as a method for all of these effects. With genetic modification, with gene editing, with anything else, you can produce things that are harmful. You can produce things that are poisonous. You can do anything else. But you can do them all by chemical breeding, by regular breeding also. You know, you could produce poisonous tomatoes or potatoes or whatever you want by regular breeding. So the important fact is there's nothing in common with all those things that could cause the sort of thing that you're talking about. What could cause them, obviously, are chemicals. I don't think there's anybody who thinks that releasing large amounts of chemicals into the environment is a good idea. And one of the things that genetically modified foods in principle can help us do is get away from the overuse of chemicals in agricultural situations. And those clearly can be having some of the negative effects you're talking about, although it's very difficult to trace. Unfortunately, it's a hugely complex problem, and people point out with allergies and things that it has a lot to do with the way babies are brought up, what they experience, and all the rest. And you know, I work for an organization run by Dr. Pat Wolf called Meds and Food for Kids, which operates in Haiti to bring life-saving supplements to babies who eat it in peanut butter, and soliciting money to try to help that cause. Somebody said, well, aren't a lot of them allergic to peanut butter, peanuts? Well, the answer is no, nobody in Latin America is allergic to peanuts. And that's kind of amazing. And nobody in America was allergic to peanuts when I was a kid. Now it's widespread, life-threatening, and that obviously is kind of an environmental thing that leads to bad causes. But it's not only something we could be doing in connection with some genetically modified or otherwise modified crops could be causing a widespread problem. But the methods of getting there themselves clearly are not, and there clearly is nothing in general with all the products you can produce. You have to measure, to be rational, you have to measure the products, not the process by which you got those products. Okay, let's go on a little bit and then we can have more discussion. What are the effects on, and some of this will be turned into the question also. What are the effects of genetically modified crops, however genetically modified, on the environment? In order to talk about that in part, you have to talk about the nature of evolution in crop plants. Edgar Anderson, who was one of my predecessors at the Missouri Botanical Garden, was a great student of what he called introgressive hybridization, by which he showed that hybridization of crops with their wild relatives and with the weeds growing with them made them more genetically variable, and then that has the effect of speeding up the results of selection. So that if you go to southern Mexico, and I did quite a long study with colleagues in Chiapas in southernmost Mexico 50 years ago, and you look at what people are growing year after year, they're not growing the same thing year after year. They're changing it and selecting it, and they can select it better and faster according to the genetic diversity of what they're selecting, according to the genetic diversity around it. So that corn, for example, there's no such thing as wild corn, but corn is selected from wild crops and is now only cultivated. As it's selected, it keeps changing, and as the different strains of corn keep hybridizing, they keep changing, and what people grow every year keeps changing, and that's just a fact of agriculture. If you want to preserve, a lot of what people talk about in attacking genetic modification is really what they think is bad, which is mass industrial scale agriculture. Mass industrial scale agriculture is characteristic of this area in the central United States and a lot of other regions. India and China, most of the agriculture is done on a very small scale. It may add up to kind of a mass agriculture in the aggregate if a lot of people are growing the same thing, but it's not like here. But it's important to know in that case that genetic modification or genetically modified crops did not give rise to mass agriculture. When hybrid corn was invented, for instance, then the whole Midwest got much more densely planted with corn than it had been before, and with a lot less room for other biodiversity in it. And what genetic modification does is allow the characteristics of the plants to be changed, and if it's done on a mass scale, that may be changing it on a mass scale, but it's not the GM products or the modern molecular genetic breeding methods that give rise to the massively growing things. It's the desire to get a lot of production out of individual areas of crops. And again, is the product something that's bad environmentally? I mean, it might be, and you have to look at that. The way crops are grown, and this is similar to the example that I was giving you about characteristics. The way plants are grown has a great effect on what they do to the environment, obviously. If they're grown in huge, enormous fields, that's one thing, if not, it's another thing. What it's important to remember here is that the expansion of agriculture from 10,000 years ago to 0 to 11% of the world's land surface is now cultivated in crops, and another 20% are devoted to grazing, mostly on native pasture land and mostly unstable, mostly unsustainable rather. As that agriculture spread over the last 10,000 years, it must have exterminated hundreds or thousands or millions of kinds of other organisms just from taking up a third of the world's surface. And it could still do that now. The object of agriculture, though, is to be highly productive within the areas where we're actually cultivating heavily, and that can eliminate biodiversity in the fields, because no farmer wants to grow weeds or have a lot of insects and things in the fields. And if people are careless, it can also eliminate biodiversity around the fields. So the monarch butterfly is a familiar example. It's much talked about recently. One of the number of reasons that numbers of monarch butterflies have gone way down is that spraying genetically modified crops that resist the herbicide glyphosate or Roundup with glyphosate or Roundup kills off the weeds in the corn or soybeans and makes them more productive. Therefore, the milkweeds that the monarchs need as larval foods that are growing in the crops are killed off, are eliminated. If the spraying is bad, if the spraying is poor, if the spraying is not focused, or if it's used on bordering areas, then you may be eliminating more milkweeds than the ones that were growing in the crops. Lots of them were growing in the crops. If we want to keep that system going, if we want monarchs to have a lot of food for their larvae and be abundant and keep up their numbers, then we have to do what a number of people are doing now, including the city of St. Louis, which is planting milkweeds around fields, on roadsides, in non-cultivated areas, crop reserve areas, and so forth. But we can't have it both ways. We can't have a world with 7.2 billion people, half of whom are malnourished to some extent, try to feed them while we're going up to 9.5 billion people by the middle of the century, and not practice intensive, highly productive agriculture. What agriculture is better or more highly productive, that's another story. It's got to be, we should be investing a lot more money in that and working it out. But genetic modification as such doesn't make it large scale or anything else. If it's bad to spray glyphosate, and I would argue that it's bad to spray any chemical that we can avoid spraying. If it's bad to spray glyphosate, then we shouldn't be using crops that are resistant to it and so forth. But whether you produce those crops by genetic modification or some other way doesn't really affect what we think about genetic modification, or shouldn't, because you can produce in a lot of different ways. Long before genetic modification was a regular method of improving crops, we had resistant weeds arising as a result of spraying too much herbicide on them. It's exactly the same thing that happens with us if we get all our bacteria antibiotic resistant. There are ways of cultivating areas so that you don't overdo the spraying and make everything in those areas resistant. If we don't use those ways, you'll be generating a lot of resistance. If you do generate a lot of resistance in the weeds and things, you've got problems, or you eventually generate resistance in the mosquitoes or whatever, as they've done with artemisinin in Asia now, you know, the latest cure for malaria, which is one of the world's most serious diseases. But again, and so I keep harping on this, but GM is used so irrationally as a slogan for what we should try to avoid, when it's actually this whole complex system that's used as some kind of cartoon to portray a force that's out there that's sort of evil and sort of settled on us, whereas I think objectively it's nothing of the kind. You know, about Europe, I've already pointed out that the same percentage of scientists there think this is fine as to here. It's the governments responding to demonstrations, pressure groups on the people that don't. I would point out that Europe has the highest use of pesticide per acre of any part of the world. And I would also point out that, for example, even in organic farming, BT, Bacillus thuringiensis toxin, you know, which you get by boiling them down and making a powder and pouring it around, is allowed in organic farming. Even though that will kill all the moths and butterflies in the whole area, that's still considered organic. But if you have a plant which has been engineered to produce BT, which therefore will kill only the moths and butterflies that are eating it, that's considered non-organic and is therefore unacceptable. There are a lot of funny twists like that in the story. But what I really want to convey to you is that it's not the GM that's the problem as such, or the method that's the problem as such. it's various aspects of the forms of agriculture in particular places that can get to be the problem. Now, if you go even talk about them in the Pontifical Academy all the time, and those would be areas like, well, if this stuff is so good, how do poor people get it? Can they afford it? Well, first of all, can farmers afford it? That's a rather easier question, because farmers can, by definition, afford seeds that are more productive for them or perform better for them in their conditions. Can poor farmers get these seeds if they're going to perform better? That's a problem like the problem of poverty overall. Half the people in the world are poor, you know, going on $1 to $2 a day or less. Half the people in the world have disenfranchised their women and children to the point where they have no rights whatever. There are lots of serious problems of malnutrition, but those are general problems of society and of functioning of the world, of the rapidly growing world population, so we can find a kind of sustainability together. In a context like that, genetically modified seeds are no different from cell phones. I mean, if we need to make them, or if society wants to make them available to other people who can't otherwise afford them, we'll find a way to do it. And if we don't care, we won't find a way to do it. But you don't improve the lot of the poor by decreasing. You improve it by living at a moderate, sustainable standard of consumption, but not by denying yourselves ways to make things more productive and the like. The problem is really, again, not one of GM, it's a problem of who gets what and why, and what do we do about it, and how do they get it. Yep?
What is your stance on patenting genes?
I don't know. Patenting life is a difficult one. On the other hand, it's fair to say, and this is not directly applicable, but I think you'll see it's obliquely applicable. It's fair to say that the regulations of things like this, many of which are patently, no pun intended, indefensible, raise the cost of all of this so much that you know, you need something to get back a reward for it. And of course, you could say that in a general way, if you invent things, you should have the right to patent them. So you can obviously go overboard. People pretty well have people stop patenting genes in general now, and pretty well, you know, the intention is always to make them patent genes for which they've been able to demonstrate a particular purpose in a particular application that they've developed. Going around and blindly patenting them, as some people have done at some time or tried to, just because they identify another gene, clearly doesn't work at all. But in other words, I suppose that some degree of patenting of advanced applications of particular genes is justifiable, but the patent law of that is an evolving thing. It's something that we have to watch carefully. Why do apples have stickers on them? Patented. No genetic modification. Now they've genetically modified an apple to turn brown so quickly, and people are running around and screaming about how awful that is. Now, what about escape of genes into neighboring wild or weedy populations? That's another question people ask. Well, keep saying the same thing over and over, don't I? It all depends on the nature of the genes. Suppose you have corn growing in southern Mexico and has a gene that makes you produce Bacillus thuringiensis Bt toxin, and therefore moths and butterflies can't eat you, or you're somewhat resistant to pests. Suppose that spreads into neighboring populations. Well, then they might be resistant to Bt toxin. They might be resistant to being eaten as much. That's not a bad thing. Any kind of gene can spread out of any cultivated plants into its relatives anyway, regardless of how the gene got there in the first place. And going back to what I was saying in the beginning, there's nothing so special about this individual case. What if the plant is bred to be resistant to glyphosate, so you can spray the fields and kill the weeds, but not the plant? What if that spreads into wild plants? Well, same thing, if they're all drenched in glyphosate all the time, then the wild relatives will live longer, but that's a specific, not an attribute of the system as a whole. Now, there are a few cases where building up resistance to spray in weedy relatives can be a problem. The two obvious cases are beets, where wild beets can get resistance to herbicides and then spread into beet fields, or sunflowers, where wild sunflowers can be weeds in sunflower fields. Those are special, have to be taken care of in special ways. What about super weeds? Well, there are about 20,000 kinds of plants in the world that are considered weeds. That's about 5% of the total of all plants in the world, if there are about 400,000. The only one that I know that's originated by hybridization between a cultivated plant and a wild or weedy relative is Johnson grass, which is all too common around our roadsides here. But genetic modification had nothing to do with that. Somehow, in the minds of people who oppose this, and there are commercial motives that obviously sometimes involved there too, anything that can be given the label GM, regardless of what is used or what aspect of it you're talking about and so forth, is to be resisted as a matter of course, and that's what seems not to make sense. And on the other end of it, I would restate that we need to do as much research on agriculture as possible to be sure that we're doing the right things to make the most productive systems to feed a hungry world that so badly needs it, which doesn't mean that any one thing should be used as a runaway, but it means that we have to use our brains to develop the best systems that we possibly can. And again, as you always seem to come back to this, it's the poor that really suffer by the lack of the application of these methods in their own areas, and ultimately the stability of the world that really suffers as a result of it also. Finally, you can talk about excess profits by companies that might have a stranglehold on X, Y, or Z, but then that's no different from any similar thing that's manufactured or made in the world anyway. It is a moral question, how much money can people squeeze out of a system and why, and what do they really own and so forth, but we'll go on debating that necessarily so for a very long time and try to reach good solutions in individual cases. So that's probably more than you ever wanted to know, but let's have some more questions. Yeah?
We've talked several times about the growing population of 9 billion people. The people that say those words often never ask, should we try to have 9 billion people? Should we actually make it illegal that people control their population in the rest of the world and we can't export help?
We would make it illegal for them?
Well,
Yeah.
What?
there are rules in Congress saying that we can't give help to people who practice various types of birth control and stuff.
Yeah. Well, that used to be one of the most ridiculous things they did, but they've managed to supersede it now with many other even more ridiculous things. Right. We've got to bring population back into focus a lot more than we do. As I think I pointed out, and I talked before I came in here, so excuse me if I'm repeating myself, but look up the website footprintnetwork.org, which is a global footprint network, which is a think tank in Oakland, which points out that we're using about 156% of the sustainable capacity of the world at the present time. And many nations are using far more than they themselves can produce or use fairly in terms of sustainability. And the 156% that was charted for 2014 is up from 70% in 1970. So a combination of population, which we're adding nearly 100,000 extra mouths to feed every day, or if you want to put it this way, every night when the world sits down to dinner, there are about 100,000 more people sitting down to dinner than there were the day before, is absolutely unsustainable and has got to be controlled. Now, the best way that I know to put a dent in that is to really empower women and children throughout the world, because in much of the world, women and children are second-class citizens. You can make some cracks about the situation here, but actually 76% of the average wage of males doing the same job seems fair to me. No. But in many parts of the world, it's even more outrageous. It means that women don't control their own destinies, and therefore they aren't really motivated to control the number of children they have. When research is done in countries like Mexico, women who've been through college have the fewest children, and the less education they have, the fewer children. Aside from that, in terms of empowering women and children, it's just a matter of, well, I always think of the motto of the United Negro College Fund, a mind is a terrible thing to waste. And those people, those women and children who are disenfranchised in different parts of the world have absolutely no way of contributing anything to us or to them or to their own societies because of the way they're being treated, either directly within their own families or indirectly by us. Then we've got consumption playing off on population. The world is driving to ever higher levels of consumption. It's rising even more rapidly than population. How do we get out of that? Well, you can't get out of that politically, because no politician is going to run successfully for office saying that what they want is for you to have fewer children and consume less, have smaller cars and less food and so forth. It's not a popular political theme. The only way that can ever change, and here I always use the analogy of Earth Day in 1970 when 20 million people got out and demonstrated about the environment, and that was 1 out of every 10 people in the US population at the time. If people get out like that and call for changes, then changes will occur. When the Congress refuses to enable what you talked about, assistance for family planning around the world, that is just currying favor with a few people, and not representing the will of the United States, and denying people around the world the things that we can do here. That's completely crazy, and but then what isn't? But anyway, how many people can the world support? Joel Cohen's book of that name brings out very clearly what is obvious, but it's worth thinking about. Depends on how you want to live. The world is getting more and more homogeneous, less and less filled with beauty and interest and diversity, less and less filled with promising options. That's why many people think that the last 50, 75 years have been the best period that the world will ever have. There's no doubt, or at least in the foreseeable future, there's no doubt that all the things that I talked about in terms of beauty, heterogeneity, and opportunity are being decreased, and there's no doubt that they will be less in 20 years than they are now. But how much less, or where the world will come to a stopping point when it reaches an equilibrium, depends on us. And if people say it doesn't matter whether you recycle or put your trash in or take your kids out to see nature because everything's going to hell anyway, that's ridiculous. Makes a big difference in a country like the United States where we're consuming so much. The thing that we need to do is develop an international viewpoint, learn, keep up with the facts of these cases so we're not just shouting blind slogans at one another like GM foods are unsafe, which is completely unscientific and counterproductive, but where we're trying to be rational, and then once we've learned, we need to vote, to act, to get out and try to change people's minds. Churches have a tremendous advantage in being able to change people's minds, because the only thing that I think will really make things better is a very widespread moral and philosophical change like we had in the 60s leading to 1970 Earth Day and so forth, that really will catch the attention of people and help them to recognize that it's time for change and that people want change. Richard Nixon didn't sign all the key environmental legislation in the US because he was initially an environmentalist, although he certainly had strong environmental inclinations. He signed it all because it became so obvious that that's what the people really wanted, were really excited about, was really important to them, and he responded to that. And that's when we did more on the environment than we have in any other period of time, that is in the early 1970s. So talk to your friends, talk to your church groups, talk to your family, get your kids out into nature, do recycle, do try to live near your workplace, and do any of the other many things that you could do, including learning about the way other people live around the world and trying to help them so as to affect the whole system in a way that can make the world a better place than it could otherwise possibly have been, in the future. Yeah.
And can you give us examples of the genetically modified foods that we use all the time that, other than like the apple, it didn't really...
Corn, soybeans, anything derived from them, soy sauce, corn oil, papaya. Most corn, about 85% of the crops grown in the United States, about 85% of the corn and soybeans grown in the United States are genetically modified, 85–90%. So the animals that eat them have genetically modified foods in them. Of course, the commonest genetically modified things we consume are beer and cheese, all of which is genetically modified, but nobody talks about it. I guess they have good trade unions, good organization, communications, yeah.
Could you say something about golden rice?
Well, that's very good. I'm glad you asked. And I didn't plant it. Golden rice is rice that is, Pat planted it, I got it. Okay. Golden rice is rice that is bright yellow. The reason it's bright yellow is it has carotene in it, and beta carotene is the precursor of vitamin A. About 700,000 children in the world go blind every year because of insufficient vitamin A, and half of them die within 2 years of becoming blind. Golden rice was developed by a Swiss biochemist named Ingo Petrikis using money from the Rockefeller Foundation. It has exactly 2 genes in it from another organism. One is from carrots, and one is from bacteria, which help to carry the other gene in. Every other bit of its breeding has been done by conventional breeding to improve the strength of the golden rice strains. And there's no commercial firm involved, none. So there's nothing. And no environmental consequence. But because it's GM, it's been fought off now for about 15 years. We first presented a lecture on it. One of the first big public lectures on it was at the 1999 Botanical Congress here in St. Louis when we had Petrikis speak. Without any commercial gain, without anything to do but gain, with only 2 genes being from a different kind of organism, that's been fought off by people saying that it's going to kill us all for the last 15 years. Each of those years, about 750,000 children have gone blind, and about half of them have died within 2 years. Is it really fair to those millions of children for us to collectively behave that way? I don't think so. There's absolutely nothing you can think of that would, in my mind, make that right. Nobody has anything to gain from it. Yeah. That are what?
They're called set-asides. They're
Yeah.
subsidies that the government provides to farmers so that they don't grow crops, which sort of doesn't seem to be agreeing with this narrative of maximizing productivity in order to feed the world. So I was just wondering how you felt about those subsidies.
I feel very bad about subsidies. New Zealand, where they did away with all subsidies about 15 years ago, is highly productive agriculturally. And I think we could be too. There are some times when they might be called for, but I think having them as a blanket form of handouts to farmers just tends to make the whole system inefficient. But again, I would call for, I absolutely feel that we need an incredible amount of additional research in agriculture, because agriculture is notoriously a field where one size does not fit all. And we need to be able to identify and put into place the kinds of agriculture that will serve us best in different areas all over the world. We make many advances, but we really don't invest in it the way we invest in health, even though food availability affects health as much as anything else. But I don't feel very good about subsidies. Yeah.
So you've talked about Golden Rice, which was created by a foundation through a nonprofit. I'm curious if you think it's possible and a good thing for the same company or group to make GM crops for profit, so something that they intend to make money off of, and a GM food for the developing world where people need different things than you do in, say, like a high input agriculture like in the United States. Do you think the same company can do both successfully, or should those two missions be separated into different groups?
The same company can produce, I mean, big companies in this field, there are about 6 or 8 of them in the world, and a lot of subsidiaries, can produce all these things, and I again think that's largely a matter of supply and demand and who pays for it. If there weren't so many regulations, many of which I hope I've given some clue to the fact I think are ridiculous, then advancing the technology is not terribly difficult. Stabilizing the products takes a lot of time. But the regulations cost a huge amount of money in this, and I would much rather see lots more people, universities, private sector people, and other people involved in it, so it'd be like what you might consider a normal field, instead of one that's so expensive that it's restricted. But I think once the products are made, then a matter of getting them around is a matter of what the world's willing to do to subsidize them. It becomes an analogous problem to drugs, although not as flagrant. If everybody in the world, if all the countries in the world said, we must have genetically modified crops to feed our people, they would find ways to lower the price, you know, as they have with drugs. Yeah.
So it seems like a lot of the lack of understanding of genetically modified organisms comes from the lack of scientific understanding. So I was wondering, how do you think scientists can actively educate the public, and not just the public within the U.S., but within the developing countries who need genetically modified organisms?
As a general problem, I think that we need to do everything in our power to try to illustrate to people what the scientific method really is, you know, starting with primary and secondary school, because it is a perfectly rational method. And when people say things like, if you're a scientist and you hear things like all the scientists are talking about global warming are part of a great conspiracy, you laugh your head off, because I don't even know any 2 scientists who are part of a great conspiracy. They're all fighting one another for glory, at least the male ones are. Anyway, educating people about the scientific method and the way science operates and what's an authoritative voice and how you find it is very important. And for that matter, as I'll say again, that we all need to educate ourselves continuously in all of these fields, because evidence changes, times change, and if you're frozen at a particular point in time, judging things in a particular way, then you'll never go forward. But lots of people are making lots of efforts to get this going in grammar schools and high schools, and I think that's just terrifically important. And demand more of media, demand more literacy of politicians. I mean, politicians saying, I'm not a scientist, and therefore I can think anything I want, that's ridiculous. On the other hand, scientists are not giving faith and morals kind of doctrine rendition of the world, and you really have to be able to understand how that fits together in order to be able to deal with that, and we all can play a major role in that. As a matter of fact, that's what universities are supposed to do. Yeah?
You made a pretty compelling case that GMOs by themselves are not inherently wrong, that it is not inherently bad to genetically modify things. But do you think there are any incentives in the way that we create GMOs that are somehow mismatched with what we want to get out of this process? So do the companies have bad incentives to move too quickly, or does the government, the way that they regulate, give bad incentives to people?
They're the most regulated crops of anything in the whole world, and there's no great reason that they should be more regulated than anything else. So I wouldn't exactly say we moved too quickly. The process of getting a stable crop variety that you can release is so lengthy that nobody's gonna rush it out. If you rush it out, it won't work. You know the saying in the military, if you want it bad, you get it bad? It's like that. No company has any interest in putting out a product. I mean, that's one thing that people seem to forget. No company has any interest in putting out a product that will poison people or be bad or hurt the environment or become notorious. That's exactly the opposite of what it wants to do. So I think not so much, I guess, is my short answer. Yeah.
I'm not a scientist, and that's why I'm here, because I want to learn. So don't squash me too hard with my general questions. That's all right. That's all right. It just seems logical if you're talking about this golden corn.
Rice, yeah.
Rice, thank you. That if you can't get vitamin A in them one way, why don't you give them carrots or sweet potatoes or vitamin A itself? While you're still working on,
Right.
moving the rice to the spot.
Because that would really require changing their entire food system, and they don't have the variety of food that we do, whereas if you get golden rice, then it's already a staple food there. That's why people settle on it as a good and easy and direct way to introduce the vitamin to them.
Another thing I'd be interested in.
Obviously, we don't have those deficiencies precisely because we do have the kind of varied diet you're talking about. But most people in the world don't. And rice is the most important single crop in the world. So if you can deliver, feeds more people. If you can deliver it that way, then you can really be sure of getting it to people, the path of least resistance.
Okay. Another question I have is on this global warming or the change in the global atmosphere environment. I had a neighbor who built a path from their house to my house through the woods that had been untouched. And the neighbor moved, and that area was left alone, and it took a season, and you couldn't see the path anymore. Nature healed that pathway.
Yeah.
Okay, now why is there not maybe you have to prove as a scientist, so that would make some sense, but why is it not logical that the earth would heal itself from whatever man does? I mean, you're modifying and you're changing the earth anyway, so why would it not respond itself to just like a scar? It changes because I've got a scar, but healing did take place.
Yeah.
So I don't understand what, there have been changes from the Ice Age and
Sure.
whatever. So why is this so dire now?
Yeah, because for several reasons, it's the quickest change that we've had to the highest temperatures, the fastest for the past millions of years. It's changing conditions so rapidly that, like the horticultural zones, the gardening zones in the United States, have moved north about 200 miles in the last, let's say, 20 years, so that now we have armadillos in St. Louis, we can grow camellias outdoors, the evergreen magnolias don't lose their leaves and so forth. But if you extrapolate that to crops, agriculture may be at its peak because crops have to be able to perform under this warmer and warmer climates. We had a symposium here at the university on global warming in Midwestern agriculture, and you know, everybody, it's very difficult to figure out how we can continue to be productive as the world warms. Now, in the bigger, in the short picture, obviously in a plant community or in a biological community, it will heal itself. And in the bigger picture, the world will heal itself, of course, but we may not be part of it. And our whole civilization, our whole 10,000 years that I was talking about, has developed within a warm period following the last ice expansion. And we've drawn out to the limits of productivity, water use, all kinds of use all over the world. And for the climate to change now with so many people spread out there in so many different places, which may actually make the cultivation of many of our major crops impossible, is absolutely dire for us. It's not dire for the world in the sense that if we all die or if we go down to no people, it'll heal itself. But we have brains. If you're religious, you believe that God gave us brains, and if God did give us brains, then we ought to use them. We'll try to make things better for us all. Stuart Brand, who's the Whole Earth Catalog originator, says if we want to play as gods, we should first think about how to get good at it. And you know, we're not really doing that. But of course, so there's several levels of time dimension involved in that. The world's not going to go away. We might go away, but the world's not going to go away. It will always heal itself.
On occasion, you'll see some groups cite less than reputable studies to back up their agenda.
Doing what?
Citing less than reputable studies to back up agendas that have no real scientific basis.
Right.
How should the scientific community as a whole respond to this in order to try to keep this at a minimum to prevent from misinforming the public?
Well, there's probably no way to block free expression, and when you have free expression that some people might find commercially desirable, as for example, disproving global warming or something, is a more obvious example that most people would agree on, it's very hard to block. On the other hand, we block it just by continuing to operate as scientists, by looking at it and go through peer review, publishing contrary evidence, and just moving on. I mean, that's kind of a simplistic answer, but it's still a very solid one that served us well. I don't think, I'm in favor of academies and people making collective studies of things, obviously, rationally, with balanced committees and good reviews, but I'm not so much in favor of individual people getting up and condemning others, because there's no end to it. In fact, you know, a lot of people condemned global warming. People who are talking about global warming now lately, people are attacking people who talk about the value of genetically modified crops. Well, they have a financial other interest in doing that. But I think you just let the scientific system run and try to get people involved in it.
Maybe this should be the last question, just to be respectful of other people's time.
Just a quick question. So Missouri recently, I think a few years ago, there was a Missouri Supreme Court ruling about a farmer and I think Monsanto. Yeah, and the case was brought before the court, and the court ruled in favor of Monsanto. So, thinking back, that Monsanto and many other companies are trying to penetrate Africa, and of course they need it for that, like Africa and sub-Saharan Africa to be specific. and Asia are probably the regions which have the most number of people who are malnourished.
Yeah,
Yeah, but looking at this, looking at this with this case in mind, and bringing it to a culture where people have grown up sort of like just planting corn.
yeah.
Should they have like concerns, or should they be afraid that once Monsanto penetrates into like the economy, they'll be forced to buy seeds from Monsanto and sort of like Monsanto banned their traditional form of like corn. So is it like a case that people from sub-Saharan Africa and Asia, should they be afraid of Monsanto and other companies like that?
Well, there's two different levels in that. The first would be the cases, you know, like in this country or something. The genes are patented, you know, the seed is patented, and if somebody does steal it or get it in some other way, you know, or if the claim is made, then that goes to court as anything else goes to court, and they either, if it drifts in there, they're not guilty. If they stole a lot of it and planted it, they might be guilty of using it without paying a fee. That's like a recording or anything else, basically, except that it's food. Now, in Africa, it's really a matter of what the laws are in individual countries. Monsanto, first of all, farmers plant what they think will get them the best return, and according to the money they pay for it. Most farmers in sub-Saharan Africa are very poor, so that small expenditures are, you know, difficult and bad. So if they buy it, it's because they thought they could produce more with it. It was cost effective. It's not cost effective, they won't buy it. Nobody will ever rule out sort of traditional varieties of corn or anything, but if farmers find that other varieties of corn are better, they will replace them, as they've done continuously during the past 10,000 years of the development of agriculture. I don't know what any individual company would do, but an individual country can do everything it wants about setting the laws or the framework on that. There's no way that a company can drive somebody out of business by eliminating their tradition with something else, unless it's cost effective. I mean, people don't use horses and wagons much anymore because there are other things that are more effective that they can afford. Everybody uses cell telephones, etc. So I actually think that's a case where the marketplace, I hope moderated by people's concern for one another internationally and within the individual countries, will take care of it. And I don't see any great danger there whatsoever.
Okay, I think we should probably stop. I will just maybe ask Dr. Rubin one last question.
No, we've already had the last one.
as sort of a takeaway, but what is one message that you would like to convey to maybe young spiritual, but also scientists, in how we can best, I guess, rationalize the ethical issues of some of these environmental concerns while also embracing these biotechnologies and, you know, sort of using our minds and science to, I guess, embrace new technologies as they emerge.
Well, I'm not trying to be flip about this, but the fundamental message is love your neighbor as yourself for the sake of me. And if you take that on board, which is a very good rule for getting along or living in any society, then you're going to develop things as well as you can by using your brain. And in developing them, you're going to apply them to all of those fields. In chapter 2 of Genesis, man is commanded to save and care for the earth. And saving and caring for it without using the tools available to us doesn't make any kind of real sense. Care for one another, learn about the world, love one another, and use the best tools available to get the most stable, productive, and caring systems that we can.
Great.